Hello, everyone, and welcome to part two of our Amazon Bedrock series. So today, in this video, we're going to be looking at the following agenda. So first, we're going to be exploring what is RAG, how we can implement RAG. So let's just try to understand what a RAG system is. Then we'll have a deep dive into what is a knowledge base, and finally, we'll look into how we can implement a RAG with a knowledge base in Amazon Bedrock. Okay. So let's get started. And first, I'll explain what is a RAG system. So if you see here, I have a diagram up on how you can understand what is RAG. So RAG stands for Retrieval Augmented Generation. So essentially, how it works is that we have a vector database here. A vector database is essentially where we have all of our data in it, right? So let's say we have a chatbot. Okay, we have a chatbot, and this chatbot, we wanted to answer some questions about let's say our company's data, right? It has some processes, how our company works, and we have a lot of this type of like data in our chatbot. So our goal right now is that our chatbot should be able to answer any type of like questions based on that data. Now, how we can implement this is that we use a RAG system. Okay, so essentially, what we do is when we have this type of data with us, that is when we need to add it into a knowledge base. So this is where a knowledge base comes into picture. So a knowledge base is essentially a modern like version of like like an SQL DB, right? So you have SQL DBs, you have like NoSQL DBs. So it's similar to that. You have a knowledge base, which is essentially a vector database. Now, how a knowledge base works is that we have some data. Okay, so we have some data, and this gets converted into embeddings. So we convert it into like vectors or embeddings. Okay, these embeddings are stored into a vector DB. Okay, so this vector DB can be anything. So you can use either like Postgres or Amazon. You can use the Amazon Open Search. So you have a lot of options for your vector DBs, and the how this data is converted into embeddings is through LLMs. So you use LLMs for this. So you can use your Azure OpenAI, you can use your Meta LLMs, or you can use any type of LLMs to convert your data into embeddings. That embeddings is stored into a vector DB. So from this vector DB, this will act as our knowledge base. So this will be our knowledge base. I'll just write it as KB here. Okay, and so that is the diagram that you can see here, right? So a user will make a query into, let's say, Amazon Bedrock. Now Amazon Bedrock has a lot of services, self-managed service for creating a knowledge base. So this knowledge base can be attached. It can take the data from different data sources like S3s, or you can have it from like txt files, from PDF files, or any other type of files. Okay, you have other like data sources as well, which I'll show in the video. And the Amazon Bedrock agents, okay, will be able to fetch the data from the knowledge base. So it will take this data that is available in this knowledge base, and then it will give that to the LLM. Okay, now the LLM has a context on our personal data, with which it will be able to make an answer, and this answer will be an educated answer because it has the data from our knowledge base. And that is also what is mentioned as a RAG based system. In general, if you have an LLM, okay, and you ask it some kind of a question, you just ask it for a question, it'll give you an answer based on what data it already has. That is the normal workflow. But if you integrate it with the vector database, which has our own our custom data in it, then it becomes a RAG system. So essentially, it augments the answer using a retrieved type of data. So that is why it's called as retrieval augmented generation system. Okay, so so I hope you guys got an understanding of what a RAG system is and how a knowledge base plays a role in a RAG system. Okay, so to just give a quick summary, the user will ask a question to a chatbot. The chatbot will, in the background, it'll use an LLM, but it'll also call upon the term into a vector DB, which is our knowledge base. The knowledge base will give some relevant data back to the LLM. Now the LLM will have some context on which, on top of which, it will be able to generate an answer. So this is how a RAG system works. Now let's just see how we can implement this in Bedrock. Okay. Okay, so now I have come to the Amazon Bedrock page here. And so the first thing that you'll have to just make sure is that you have to be logged in with um, a different user apart from your root account. If you're in your root account, it doesn't allow you to create a knowledge base. So just keep that in mind here. Okay, and the next thing you have to make sure is that you have to make sure you have the different like model access. Last video I showed you guys how to get the access, but when you're changing to a different user, you have to again request all of the access for that particular user. So just keep that in mind. Right now I have asked for access for all of the Amazon models. Okay, for the sake of this demo, I think that will be fine. Now let's create a knowledge base. Okay, and as you can see here, we have different types of offerings by Amazon on creating a knowledge base. So we can use a vector store, which is basically for unstructured type of data, right? You have some documentation about your project, you have some unstructured like Word files, text files, PDF. So all of that can be useful for a vector store. Structured data store is for, as the name suggests, for structured type of data. So if you have your database tables, your CSV files, so all of that can be put into a structured data store. So right now I'll just show you that I have a notepad file here with this type of data. So I just have like 3 sentences, which is going to be our knowledge base data. So my name is Lennox, I'm living in India, and today's date is August 6th. So these are the type of data that I'm just going to put in this like text file. And one more thing I have already done is that I have created one S3 bucket. In that S3 bucket, I have added our text file here. Okay. So with this already set up, let's go to our knowledge base tab, and I'm going to click on the create button. I'm going to click on the knowledge base with vector store option here. Okay, now that we are here, we have to give our knowledge base a name. I'm just going to call it knowledge base YouTube demo. Okay, and you can give any description here for it. I'm going to just make sure it's on the create and use a new service role. And coming to the data source type again, so Amazon gives us a lot of predefined options on how, on which like data sources to use to set up a knowledge base. So either we can configure it to get the data from an S3 bucket, we can point it to a URL and ask it to crawl that website, we can directly upload files into this knowledge base, or we can integrate it with SharePoint, Salesforce, Confluence. So I think you get the idea here, right? So right now I'm going to go ahead with the Amazon S3 option, since I already have uploaded my text file into an S3 bucket. I'm going to go down and click on the next button. Data source name, I'm just going to leave it as it is, or I can even call it knowledge base S3, so that I know that this is the S3 data source. Okay, and this location is going to be in our AWS account. I'm going to click on the browse S3 option. I'm going to select the bucket in which I have my files. Click on choose. For the parsing strategy, I'm going to go ahead with the Amazon Bedrock, like the default processor. You can also choose any of the other foundational models for your processing, right? You can choose all of these models. Right now, we're just going to go ahead with the Amazon Bedrock's like default processor, as it does a really good job here. And you can also define your chunking strategy. So chunking is essentially how you want to break up the data and store it in the vector DB. So I'll just going to leave it as default chunking for now and click on next. For the embeddings model, this embeddings model is the one that converts our raw data into vectors or embeddings. Okay, so for this I'm going to go ahead with the default Amazon's like Titan text embeddings v2. uh, and here in vector store, I'm just going to create a new vector store. Okay, and we have two options. We can either use OpenSearch serverless or Aurora Postgres. I'm just going to go ahead with the OpenSearch serverless option here. Click on next. It'll ask us to just review the details we have inputted, and we can click on the create a knowledge base button here. So now this, as you can see, this will take some time to like finish. So once it's done, let's get back to the tutorial. Okay, so now you can see that our knowledge base is successfully created. A service role has been created for the knowledge base. You can see that the data source that we added, which is basically our S3 bucket, is also created. But now if you go into a data source, you'll see that it doesn't have any like documents in it. That is because we first have to sync our knowledge base with this data source. Okay, so you can just click on the sync button here at the top, and what this will does is that it'll pass through our particular data source, fetch all of the documents there, and then it'll update it in here. So once this is done, you'll see that our document will be added here. And yeah, I think now the sync has been completed for the knowledge base. This happened pretty quick because we don't have much data. So let me just refresh the page, and I think we should be able to see our documents here. Yep, as you can see here, it successfully indexed our text file. It is currently in an indexed mode. Okay, and you can see that it'll show you all the times when it was synced into our knowledge base. It's perfect. So now our knowledge base is successfully configured. Now let's go ahead and configure our agent. Okay, so now we'll see how to set up our RAG system. On the left tab, you can see there is a build option here. Under that, you can click on agents. Now here you can create your agents. Here you can set up a multi-agent workflow. In this video, we'll just look at setting up a simple agent. In the next video, we'll look at how to orchestrate between multiple agents. So click on the create agent option. We'll just click agent YouTube demo. Okay, YouTube demo. And yeah, so if you enable the multi-agent collaboration, this will make this agent as a supervisor agent, and it'll expect us to assign some collaborator agents underneath. Right now, let's just go ahead without checking this box and click on the create button. Okay, so now you can see that we have the agent name already set up, and here now we have to select a model for our agent. So this is going to be the brain behind our agent. We are going to choose an LLM here. Now for the LLM, you can see here there is a checkbox which says Bedrock agents optimized. Now if I unselect this, you will see we have a ton more options here about all of the models we can use. But these models as of now are not optimized with Bedrock. So for now, let's just go ahead with the ones which are optimized and for which we have access to. So just go ahead with the Nova Pro version here. Click on apply. Okay. And for the instructions, so this is where you have to give a detailed prompt on how the agent must behave. So this is where you have to mention how the agent must interact with the user, what the agent should do, how the conversation will look like. Okay, so I'll just like type out a prompt here real quick. Okay, so this is the instructions that I've given for the agent. So this is going to be a prompt which is essentially going to be passed in with the LLM. And right now, I've given it instructions that I've said that you are a question answering agent. And I have said that you will answer the questions only from the knowledge base that is assigned to you. If you do not have the information, I've asked it to say something like, I'm sorry, I don't have the information in the knowledge base right now. So this is the instructions I've given it. Right now, let me just save this for you. Okay. And we will see how this particular agent is able to answer our questions. So it'll just like take some time to save it, and after you save it, you also have to prepare it. So only if you click on the prepare button, it will update the agent with the latest changes. So now that it is successfully prepared, let's just ask it some questions. So let's just say hi, how are you? So right now, as like a typical LLM, it's able to just give us responses. Hello, I'm here to help you with any questions. How can I assist you today? So now let's just ask it, what is my name? Okay, and we'll see if it's able to answer this. What is my name? Okay, so now you can see that it's giving us the reply that it doesn't have that information in the knowledge base right now. And this is because we haven't associated this agent with the knowledge base. So it does not, right now, it does not have the context enough to answer these questions. And even if you ask it what is today's date, it won't be able to answer to this question because this is an LLM that does not have access to the current data. So now to just show you how it can answer these questions, let's add our knowledge base to this agent. So if you scroll down, there will be an option called knowledge base here. You can click on the add button, select the knowledge base that we just now created, and here we have to just give it some information on what type of data is present in the knowledge base. So I'll just say that this knowledge base has some personal data. I'll just mention it in a very simple way, but in a real life use case, you have to be as elaborate and as precise as possible for the best results. Cool. Now we have added the knowledge base. You can see it's in an enabled mode. Okay. We have other options like guardrails. For now, let's just ignore that. We just go ahead, click on save one more time so that we can click on the prepare button. Okay. So now that we have prepared the changes, let's just close these messages and ask it the same questions. Now we'll ask it, what is my name? It's going to just think a little bit, and now it gave us the result. Your name is Lennox, and it even gave us the data source on from where it took. So it identifies that it took it from this text file. It's able to answer. Same with the other one. So we can ask it, what is today's date? Just ask it this question, and you can see that it's able to answer that as well. So this is how a RAG system works. This is an extremely simple example of how we're creating a knowledge base, adding some data into it, syncing the data into the knowledge base, and then we're attaching it to an agent so that that agent is able to answer questions based on it. So yeah, that is it for this video. In the next video, we'll look at the other options. So there are a ton of interesting options such as this multi-agent collaboration where we can create multiple agents, and one agent can be a supervisor agent and the others can be collaborators, so that one agent can pass the information to other agents and have an orchestration within the Amazon Bedrock ecosystem itself. So I hope you guys like this video. If you liked it, please like and subscribe to the channel, and stay tuned for part 3 of this series. So thank you guys, and see you in the next video. Bye bye.